Action.
Hi, my name is Francis Lynn, and I'm the developer of the microtile programmable logic controller. Microtile is a PLC that is designed to run on the very popular Arduino series of microcontroller boards, specifically the Nano and the Uno controller boards. Microtile is a small, self-contained, efficient and very economical PLC. It comes in a small footprint and it is capable of being applied to a lot of your home automation controller projects. Now we'll spend the rest of the video introducing you to Microtile. Here we have the Nano controller board, and this, as you can see, is quite small. It comes with the 80 Mega 328P, in which Microtile has been pre-programmed. Because this chip is already soldered onto the board, it comes with the board already programmed. If you're planning to use this controller board, we highly recommend that you get one of these mating breakout boards. The first type of breakout board comes with a set of screw terminals that allows you to connect your external input-output connections from the rest of your control circuit easily to the Nano board. If you're using the Nano and Microtile in a more complex project where you need many connections, then you could go to this type of breakout board with the strip headers on either side for the input-output connections. Next up the ladder is the Uno microcontroller board, which was one of the very first Arduino boards that was put into production. This board uses a plug-in 80 Mega 328P controller that comes in a 28-pin DID package. The I/O connections are on either edge of the board using these female strip headers. The advantage of this board is that if you already own one of these Unos, you can get Microtile supplied in a pre-programmed IC controller here, the 328P device. If your controller needs are even larger than what can be supported by the Nano or the Uno board, then Microtile also comes pre-programmed in this Mega 2560 controller board. This board has an extended Microtile version in that it has twice the memory space for user programs than the two smaller versions of the board. Now let's go on to the demonstration that will showcase some of Microtile's features and functions. I'm going to explain to you a test rig that I have set up to demonstrate some of the Microtile capabilities to you, to give you really an overview rather than a detailed description of the programming for Microtile. To do this, first thing I have to do is to explain to you the test rig, and here is a simple schematic of the test rig. Here we have the Microtile PLC, and on the left side there are inputs, and we're using 2 of the 6 inputs labeled A0 and A1. These are connected to push button switches labeled switch 0 and switch 1. On the output side we have 3 of the 8 outputs that we're going to be using. First of all, the first output is Y0, which is used to drive status LED 0. Output Y1 drives status LED 1, and the output Y5 drives a relay that in turn switches on 120 volt AC power to an incandescent lamp here that is powered up from the 120 volt supply. Now let us show you the test rig briefly. So here it is. The Nano controller board is plugged into our breakout board with the screw terminals. On this side we have the input connections. On this side are the output connections. Here is switch 0. Here is switch 1. This is LED 0, the status, LED for switch 0, LED 1 on switch 1. The relay that is used to switch 120 volt line power to the incandescent lamp, and this is driven by output number Y5. To get the system up and running, all you need to do is to plug in your USB communications cable to your host PC, and finally, in order to communicate with uTile, you will need what we call a user interface, which is just simply a terminal emulator program running on your PC. uTile requires a terminal interface program running on a host PC as its user interface. About the only requirement for this terminal interface is that it be a VT100 compatible type terminal. This means that the terminal has to understand escape sequences, which are used to control the cursor positioning on the screen, clearing the screen, erasing the line, and also setting the display attributes for the characters. Now there are several terminal emulators that are available that work quite well with uTile. It depends on the operating system that you're using on your host PC. Windows being one of the most popular operating systems, you could use a terminal emulator that comes with the communications program called TerraTerm. In our demonstration, I'm running a Linux operating system, the Debian 8 version, and on this system I'm going to be showing you 2 communications programs that work also quite well with uTile. The first is called Kermit, and the second communications program is called Minicom. So let me start up the terminal emulator and show you how it operates. So I open up a terminal and I call up Kermit. Now the uTile is already plugged into my PC, so when I start Kermit, you'll see the sign-on screen for Nano appear on the terminal. This screen here is common to all versions of microtile. It consists of several parts. The top line is the title line, and it tells you we're running microtile on a nano controller board using an 80 mega 328 controller. In this area of the screen, we have a data display area which shows you some important parameters for the tile engine that's operating on the microcontroller. This is what we call a bit stack display, which displays the 8 individual bits of a bit stack byte that is quite central to the operation of microtile. Then we have a data display where the user can enter numerical data for things like timer settings, followed by a port byte display, which is another bit display consisting of 8 bits for the internal ports that microtile knows about. In the central area of the screen, we have a display of 32 lines of microtile commands. Right now they're showing you that the command in this space is actually filled with uninitialized data, which shows up as 5 dots. Then below we have the enter field where you type in tile commands, and below on the last line is the status line. The status line shows that we're using user file number 0. Now what you're looking at is the command editor for the microtile engine that is currently operating. Microtile has 2 operating modes. One is the editor mode, where you enter commands and you control the actual operation of microtile. When you load up a program and start executing it, microtile switches to the run mode, where the entered program is run continuously at high speed. Now, let's begin by showing you a couple details of how to navigate around the screen. From your terminal keyboard, you use the up and down arrow keys to move the backlit cursor to whatever program line you would like. If you use the left and right arrow keys, look what happens. You scroll to another page of 32 program lines. There are 8 pages of 32 lines, which means a total of 256 program lines. So on the 255th line, if you scroll down one more line, you roll over back to line number 0. When microtile starts up, the user file 0 space, as I said, is uninitialized. So the first thing you'd like to do is to fill it with a known command, and in this case we use the no-up command, which is just a command, a placeholder for other commands that does nothing. But if you execute it, it just goes down to the next line and does nothing. The second thing I would like to show you is the built-in help screen, which you enter by typing the question here, and this brings up the tile help screen. Here you have a concise listing of all the commands that are available to microtile. There are logic commands, bitstop commands, I/O commands, what we call interpreter commands, commands for invoking timers and flip-flops, the byte commands that call up the important ports that microtile uses, and some internal clock commands here. To get a full understanding of the command set, you need to take a look at the generic microtile programming manual that's available on the plcchips.com website, which we encourage you to take a look later. This instruction manual is fairly detailed and has complete technical descriptions of microtile in general, so I won't spend a lot of time explaining each command here. Now let's enter the first of our demonstration commands. Demo number 1 will just show you how to read an input from switch number 0. So you recall that switch 0 is connected to input A0. So we read it in, we invert the signal, and we direct it to the output, which is on the indicator lamp or the incandescent lamp. So we type in a breakpoint command, and then we type in the end command. So this comprises our program. Now we type in execute 0 to start the stored program. And notice that it says we're running the user file program. Now if you look below at our demo board, I'll show you that whenever you press switch 0, the microtile engine picks up the input and simply transfers it to the relay. So here you see, by pressing the switch, we are able to turn on the load. Now to show you how simple it is to modify a microtile program, let me break out of the program by striking the slash key. Then it says here, strike any key to return to the editor mode. The status line shows you that you're now back in the editor mode. Now, A0 was looking at switch 0, so I'm going to just change this to switch number 1, which is on input line A1. And I'm going to start the program again by typing execute 0 to run the program. And the new program is now running. Now if you look back on the demo, here if you press switch number 1, you notice that the light now flashes. So the control moved from switch 0 to switch number 1. We can modify this program again simply by breaking out the program. We go back here, then we enter 3 new commands by doing an insert to make space in the program. Then we type in our new instructions. So I'm looking at switch number 1, inverting it, looking at the next switch, inverting it. Then I'm ORing the results and sending the result back to the relay to drive the lamp. Notice here that I've read in the two switches, inverted the switch signal, and using an internal logic command OR to combine the two results, and then I'm sending it to the relay. I'm going to start the program again. And looking back at our demo, notice the action now. You press switch 1 or switch 2, then the lamp is activated. Now we're going to modify this program even yet again to show you how versatile the programming of microtile is. We break out of the program, and then I'm going to introduce one of the internal clock signals here and show you how it can be used to modify the output. So I go to the command line that directs the output to the relay, then I insert 2 empty spaces, then I'm calling up a clock signal which is generated internally, and I use another logic command AND to combine the original output with the clock signal. Then I'm going to execute the program once again. So notice the running user file program status message appears here to indicate the program is now operational. If you look at the demo, look what happens when I press. So now that concludes demonstration number 1, and we'll continue with demonstration number 2. First, let's break out of the program, clear the screen with the fill command, and then call up the help screen. Now, microtile comes with some internal complex functions, which are the timers and the flip-flops. There are 16 timers and 16 flip-flops. The timers T0 through TB are seconds timers, and TC through TF are minutes timers. The numbers here run from 0 to 9, then A through F. So there are 16 numbers in this hexadecimal numbering system. Notice now the flip-flop functions has 2 control inputs, a set and a reset, plus an output function. Flip-flops are latches or memory elements. So we will now demonstrate how to use the flip-flop. So we go back to the program screen, and I'm going to enter the following program. Input A0, invert it, then direct it to the set input, take input 1, invert it, direct it to the reset input, take the flip-flop output and send it to the relay, enter software breakpoint, and then execute the program. So we're running the program. And if you look at our demonstration rig, you press the set button, the lamp goes on, and the flip-flop latches in the input result. So you press it, nothing happens. To reset it, you press the reset. So it's a set reset function. For demonstration number 3, let's go back to the help screen for a moment. On the I/O commands list, on the input, you'll notice there are 4 types of input commands. We've been using the AI command, and I runs from 0 to 5 for the 6 inputs supported on this version of MicroTile. Here we have the double action input, which is a toggle function that is provided on each of the inputs to MicroTile. So we go back to the editor screen, and I'm going to show you how to use these functions now. So we call up the first toggle function on the input 0, the toggle function on the input number 1. Then we combine the 2 inputs using the logical exclusive OR command and direct the result to the control relay. Enter the software breakpoint, end command, and execute the program. Now notice how this program operates, looking at our test rig. Each time you press an input switch, the state of the incandescent lamp changes. This demonstrates some of the built-in functions that are available on MicroTile. Now we go on to demonstration number 4. For demonstration number 4, we're going to show you how to use the timers that are available. So first of all, let's fill the program space. Then we call up the help screen again, and notice that the timers here, we have 3 commands associated with it, plus a command called LDT. This LDT is actually for loading up the timers, presetting them with the time delay values you would like. The TQ is the timer output, the TK is the timer trigger input, and the TR is the timer reset input. So let's break out and we enter the following program. We're going to use input from switch 0 to trigger the timer. So we call up the input, invert it, and we're going to select timer number 0. Call up switch 1 input, invert it, and direct the result to the reset input of the timer 0. Call up timer 0's output, direct it to the relay, enter a software breakpoint, the end statement, and then we're going to execute the program. Oh, we made a slight omission, so we forgot to load up the timers. So I'm going to call up the timer loader command. Now what this shows you is the setting for each of the individual 16 timers, timer 0, 1, 2, etc., to timer number F. These values you see here are due to the initialized inputs that exist for the timer. So if you look on the status line, it tells you entering a Z will zero out all the timers. So we've zeroed everything out. And then I'm going to enter a setting of 3 seconds for timer 0. When I'm done setting up the timers, just a blank line will bring me back to the main screen. Now I can start the main program. And if you switch down to the test rig, let's see what happens. So this will set the timer, and notice the lamp comes on for the predetermined 3 seconds. If you start the timer, you can reset it immediately. Again, before it times out, you can always reset it. Now that concludes demonstration. Now in demonstration number 5, I'm going to show you one of the features of microtile to store the entered program in the user file into a non-volatile storage space. Microtile supports storing and loading from E² RAM, which is a built-in memory area of the microcontroller. So taking the example program that we have demonstrated in number 4, we will now show you how this file can be stored to EEPROM. You enter the command to store the file. Notice it says storing user file 0 on the status line, and now it's done storing. You strike any key. So the file in user file is now transferred to E². User file 0 resides in the internal RAM of the controller. So if you remove the power for any reason and restore it, the memory gets erased. Your contents of your program will disappear. So let me clear out the current user file, and I'll now recall the file that was stored to E² RAM. Now, to do this, you enter the load command, and notice that the file reappears. Now, in the next demonstration, we're going to show you another method of saving your file to a disk file on the host computer, which is outside of the microtile controller platform. Now, microtile also supports storing your user file to an external disk file on the host, and I'll demonstrate that using the current program. To do this, you need to exit back to the Kermit command line, which you do by entering a control \C, and now you notice you're back in the Kermit command line mode. So to save the file or to download it from microtile, you type the download Kermit macro. And we're writing a file, microtile.hex. This file has been saved on the disk on their host computer. So notice I've cleared out the user file 0. So it's empty, and I'll call up the timer screen and I'll also clear it out. So that shows you that the microtile is completely blank. Now to upload the file that was saved to disk, we exit back to the Kermit command line and type the upload command. We're reading back the file that was saved, and there it is. So that was meant to just demonstrate the upload and download commands from Kermit involving disk file transfer. For demonstration number 6, we're going to use the file upload and download feature. Now I've already written up an application program that is fairly long, a little bit longer than usual, and I'm going to upload it back to the microtile. So first, let's get rid of this program, clean out the timers, so we are back to an empty state. Then I'm going to exit back to the Kermit command line. You do that by entering Control / followed by C. So that brings you back to the command line. Then I'm going to upload a file called uTile.hex. So we're reading the file and sending it back. File read is completed. Go back to the command line for Kermit, and that's the program. Now if you call up the delay timer loading screen, you'll notice timer 0 has been set to 3 and timer 1 has been set to 1. And let us execute this program and see what happens. This program demonstrates 2 timers that have been cascaded to give a constantly running timer stream. We can stop this demo by just breaking out of it. The last demonstration, number 7, is also been pre-written and saved to a disk file. So now let's retrieve the file. We can back out of the microtile command screen. Oops. And we're going to upload the program called PB timer hex. It gets loaded up to microtile, and there's the program. Now let's execute this and see what happens here. So looking at the demonstration board, when you press this push button, the timer starts and runs for a time delay that's set up. But notice I can abort the timer by pressing the push button again. So I can start it using the same push button. I can reset it. If I start it and leave it, it just runs until it times out. I hope these sets of demonstrations give you an idea of the versatility of using microtile PLC in your controller applications. If you're interested, please visit our website at plcchips.com for more detailed information. Thanks for watching. Bye.